Hello, you are now listening to the Modem Podcast, where we deconstruct, examine, and discuss deeply technical data networking and information technology topics. Sit back and relax while we fire up Dial D and the 9600 baud modem and connect to the Wildcat BBS.
Hello, and welcome to a January 2022, probably February by the time you listen to this, episode of the Modem Podcast. Today, we have some extra special guests. I mean, all of our guests are special one way or another, but these guests are extra special. One, you would probably know from a prior episode that we did on that wonderful topic, buffer bloat. His name is Dave Taht. How you doing today, Dave?
Hi, everybody. Glad to be here.
It's the Dave startup sound. And our other guest, you may not know, or maybe you do, if you've read some of his drafts and community work lately. His name is Seth Schoen. How you doing today, Seth?
Doing great. Thanks for having me.
Absolutely. I'm excited to hear talk about some of these things here. With me, as always, to keep me from rambling and all the nonsense and stuff that comes out of my mouth is Chris Cummings. Chris, how are you?
Nick, I'm doing pretty well. I'm doing as good as 9K MTUs on the internet. How good I am.
End to end, baby. End to end.
End to end. Yeah. But I'm really excited to talk about something that's totally not controversial today.
Oh, yes. Not controversial at all. So, yeah, Seth, some stuff happened. You wrote some documents and people's hair caught on fire about it.
Yeah, I'd say so.
Let's dig in a little bit to that.
Gosh, did April Fools come early this year? Or all sorts of choice words. Yeah, Dave and I have been working for John Gilmore on a project called IPv4 Unicast Extensions. And this has to do with efforts to reclaim various IPv4 addresses that have been going to waste, in most cases for decades. We finally published some internet drafts about this, and they got a lot of controversy. I think one of the unfortunate things is that one of the four drafts got so much attention. The one that got the most attention, I think, and maybe this is why it got the most attention, but it's perhaps the most difficult of the four to implement and deploy. And I feel like a lot of people didn't even know that we had four drafts. They heard about our attempt to repurpose the loopback network, and a lot of them said, "What? You can't repurpose the loopback network?" And they never heard about the overall project and the fact that we had four drafts, not just one.
Yeah, that's certainly the one that blew up the most, I think, from my point of view.
Have you gone mad?
I think as technologists and humans, the tendency is to look and see the thing that is the biggest fire and go, wait a minute, I can't see anything other than, the giant elephant that is crushing cars. And the other things around it, the periphery, the collateral damage, as one would expect, is largely ignored because that one thing is happening. But
yeah, I was just on a forum and someone wrote a great historical post with lots of research and talking about these colonial history things and like thousands of words of research. And I read it and it jumped out to me, one of the plurals is wrong in one of the indigenous languages. And so I wrote a reply that was like, you got one of your plurals wrong here. So I do think there is this human tendency to say, what can I disagree with or what can I object to?
Yeah, I think it's very natural to just by default, see something, and even if it's great, just to kind of go, oh, but here's something that can improve. And I think honestly, a lot of people do that from a position that is well intended. However, sometimes it doesn't come across. Now, I'm not going to stand here and say that maybe all of the discourse that happened around these drafts was incredibly to the open forum of discussion.
The flames did die down some, and there was some constructive discussion, particularly on the NANOG mailing list. People like Dave Curran and I forget who else showed up with not exactly enthusiastic support, but they were willing to talk about it. And so I would really like us to not talk about the one that caused the flames first. Let's feed you the drugs slowly and gently. Try to make the argument.
Oatman model. The first one's free.
Yeah.
First one's free.
So I think
first three are free.
A little bit of history. Yeah. So a little bit of history for those that may live under a rock or not know or be on the moon. We're out of IPv4 space in the RIR space. So, we'll probably talk a little bit more about, some detail around that later. But if you go and ask for more IPv4 space, or as I like to call it, legacy IP space from, let's say, Aaron, unless you're asking for a transition block, which is to say they'll give you a small, like a /24, if you're going to use it to transition from IPv4 to IPv6. You may be able to justify getting something like that. But for the most part, the days of going and asking for a 20 or a 19 or really even a 24, they're gone. Like you can't get more space. And so because the move to IPv6 has been so unbearably painfully slow, people are looking around for other options, right? And, they're trying to reclaim space that isn't used. They're trying to get darknet space that's allocated, but not been in the DFZ, the default free zone, for 20 years, because there's actually quite a bit of that too. And repurpose some of these things that are there, but maybe not being used in the best way they could be. And it feels like that's really the spirit of what you're trying to do with these drafts here. Am I way off, or is that the intention here?
Right. So John Gilmore, who founded this project, has been involved with this personally. He's on the board of a nonprofit called Amateur Radio Digital Communications, or ARDC. And ARDC was one of the organizations that got one of the large allocations many years ago, when IPv4 scarcity was just less of a recognized or less of an imminent threat. So there are lots and lots of organizations that in the 80s and early 90s were able to get what now would seem like enormous allocations, historically for free, and historically without having to very extensively justify them.
Hey, John, can I get a /8 for this? Sure. What do you need it for? I don't care.
That John would be John Costell, right?
Yes.
Yeah.
So that would be I think it's the 44 net, right? That was allocated to the amateur radio space, 44/8. Is that right? Yeah.
And it's a typical example where it's clearly a good thing for amateur radio operators to be able to use IP technology. It's clearly worthwhile to get them on the internet. And then it turned out that particular size of block that they got went mostly unused for decades. Most of it was not publicly routed for decades. And so the current board of ARDC was able to make a deal to, I think we can say, sell a portion of that space for a very considerable amount of money, which they're now using for other nonprofit purposes. And I think going through this process, John Gilmore, I think said, well, there's a lot of demand out there, and the IPv6 deployment has not made everyone say, oh, I guess we just don't need any more v4 space. A lot of people, I think most especially cloud hosting companies, certainly many other kinds of organizations too, but I think most especially cloud hosting companies are saying, our customers find it necessary to have IPv4 space so that half of the world or so can still reach them. And if we couldn't, as cloud hosting companies, give v4 space to our customers, they would find it very, very difficult, depending on who their target audiences are and what kind of services they're offering. And so some of these companies are quite happy to pay very considerable amounts of money for this space. And I think John's intuition is that is really a sign that there's value to be had in satisfying that demand. I think John has felt that when there's market demand, it shows that people value something. It shows that they feel that they have a constructive use for it. And certainly people can come and say, you shouldn't want that v4 space. You should be pursuing other technical approaches. But I think the people who are behind that economic demand are saying, we have a use for it that comes from real customers saying that they really need it. And they really need it for concrete reasons about their own business needs. And then I think the other side of that is that experience with the ARDC network showed John, wow, there's a lot of stuff out there that was allocated or reserved in some way in the 80s or the 90s that's actually never been routed on the internet, or that's actually never been routable on the internet. And potentially, if we can have the right conversations and find the right people, we can change that. And now it's so clear that these addresses would be so useful. You know, maybe in 1982, in 1984, in 1987, I can mention all the years in the 80s, but maybe in some of these years, it wasn't that clear that it would be a big deal if you set aside a /8 for something, /4 for something.
Multicast, even that OSI was going to be the future. Okay, up until 1992 was just an experimental network, and then, whoops, it became the real thing. And then we needed to add in OSI again, starting in 96, and we just missed the window. We're stuck with IPv4.
I mean, it's interesting. If you go back and look at the list of early allocations, there are quite a few. So we're going to talk about addresses that were reserved, not addresses that were allocated and then unused, but addresses that were reserved with special meaning, which is what our project is about. But there's lots of others that actually were allocated to organizations that have not used them or have not used them publicly.
Yeah, there's a significant amount of those that exist out there. We've actually done a prior podcast on some, the DoD space that was announced and then yanked, and that's a drop in the bucket. Like, there's a lot of that still exists, because people may hear the term grandfathered, right? That's what we always call it. Like in the research and education space, we were some of the first that had, because the internet came out of R&E. So, in the military. So like a lot of the original nodes were at universities and research facilities and things like that. And so there was a lot of space allocated in that way, which is considered grandfathered space, in that you don't need, like, the billing model is different. It happened before any of the whole structure existed. And so it has different policy applied to it.
It basically happened by John Postel using a text editor.
Yeah, I have no doubt.
So I think, Seth, one thing you said that sticks out to me as important in this discussion is, what you guys are trying to do here with a lot of these Unicast extensions and these drafts, which we'll get into the details and the nitty-gritties of them, of course. But one thing you said that stuck out to me was that it's really important to have a conversation about it. And that's something that also, when you brought up 44/8, there was definitely no drama around that one either. That totally went off with no people complaining whatsoever, and everybody was happy and lived happily ever after, right? So, I think that, to me, a big theme about all this stuff is, the internet's made of humans, and we need to have discussions about this stuff. And what I do fear is that, a lot of times when stuff like this gets brought up, there's just this lack of desire to have discussions around it, even if it's something that on its face sounds really scary. It's like, oh, reuse the loopback space, that's going to break my application and stuff. But we're not going to know what we can do until we try. And this is one of those things that, Nick and I talk about this all the time, that really drives me in my life. It's don't tell me that. I think I'm stealing this exactly out of Nick's mouth. It's don't tell me why I can't do something. Like, tell me how we can work to make this happen. And that's like what I think it's important to keep in mind when we're talking about this. And yeah, I just, when you get on the internet discourse, it usually just turns into minor details about everything. But I do think it's important for us. I mean, the internet is by people and for people. I really like RFC 80, 90, something like that. Yes, thank you. Exactly. The internet's for end users. Like that's who we're here for. Like, I think a lot of times we lose the scope of that. We lose sight of that when we're network engineers who, we're all technical folks. We're in the weeds and we get down deep and stuff. And, you hear people like, well, not on my network. You can't do that. And, that's not how I run a network. And I just really, would like to encourage people as we, dive into this, like keep an open mind, think through, what benefits this could gain, to the internet. And especially in, places of the world that, aren't as privileged as we are here in the US. I think that's who can really benefit a lot from some reclaimed space. I think that there's a lot of stuff here that's actually really valuable if you come to it with an open mind.
So there are certainly a lot of complexities. We'll talk about the installed base of devices that refuse to talk to some of these addresses. And that installed base exists, and a lot of people point to that. I think one thing we should emphasize in the spirit of that discussion that you mentioned is that we don't know for sure that this will work. And assuming that it will work or can work, we don't know for sure on what timescale it can work. And so something that I keep coming back to is that the use of 240/4, the former Class E, which is one of the things that we propose, was publicly proposed at IETF in 2008. And it was actually proposed by two different groups with slightly different drafts. Right? And there was a lot of negative reaction to it then in 2008. And one of the objections that some people raised was, by the time this becomes actually useful in terms of software updates and software fixes, we'll all be entirely on V6 and we won't need it anymore. And
I wish that was the case.
Yeah, I mean, I wish that was the case too.
Can I do a little more historical context, though, from 2008, maybe? So for starters, Jeff Houston was on the other side, and he just wrote a really great piece. It's not exactly a mea culpa, but it's a really great piece that looks at the kind of decisions that we made then and the kind of bright, fuzzy future we saw. They saw in that particular case that the iPhone was exploding and that IPv4 was going to run out, and we were not ready to convert over to IPv6. So 240 was proposed by those two different groups. One of them wanted to be reserved space, one of them wanted to be public space.
Reserved in the sense of private, not in the sense of invalid.
Yeah.
Like RFC 1918 stuff.
Yeah. And the thing is that all the OS developers in the world, except one, thought it was a good idea. So we did it. Over the course of a couple months, 240 support landed for everything. And then the draft died. And we all been shipping code, with one major exception, that works on the 240 space.
Yep.
Go ahead, Seth.
So if we look back to 2008, there's this real sense of frustration and missed opportunity, at least for me, in the sense that a lot of people said, I think entirely in good faith, well, that's going to take a while to get the operating systems updated, and surely we won't need it.
Yeah.
At that point. And of course, it's now 2022, and those addresses would be very useful to lots of people. And if we had all said yes to it in 2008, we would have had all of that time in which to work on getting devices updated to support it. But we essentially lost that time window and lost that opportunity through various concerns, including the confidence that it was never going to be necessary, never going to be beneficial. And so we've been saying, at least in my perspective, it would be a great thing if V6 adoption continued at a pace and to an extent where most of this demand for v4 dried up, or where the v4 scarcity went away. That would be a wonderful thing. We can definitely encourage people who are working on v6 adoption and working on v6 rollout and say, yeah, that's a really valuable, important thing for the internet that definitely needs to keep going. And we can also say, if we start doing these changes that we propose now, we maintain the option that in a decade or a decade and a half, this may be broadly useful. And we might say, unfortunately, it may be the case that v6 is not ubiquitous enough to eliminate demand for v4 space at that time. And then we can say, well, we now have this additional option that's meaningfully available and usefully available to a lot of people because we set it in motion.
I think one of the important things that you're saying here, you're saying it without saying it, is that, and we come across this a lot, because we say that this is a thing that needs to happen, a lot of folks will say, well, if we just do this instead, then we don't need to do that. But I'm saying, why not, why not both?
Yeah.
Like they're mutually exclusive. They can both happen at the same time, and they should probably.
Well, all the technical work most of the technical work is done. It's figuring out deployment. And we've kind of jumped in on the 240 thing. The audience who has not been subject to the Reddit isms still doesn't know what we're talking about. So
so we have 4 kinds of addresses that we're looking at, which in each case were given special meaning at some time during the 1980s, so that they can't be used for unicast addressing under existing standards. Unicast addressing meaning to identify a device on the internet in the ordinary way that you get an IP address. That's a retronym, as people say, after they invented multicast. They said, wait, what do we call the old thing now that we have multicast? Well, the old thing is unicast. So the special cases in the 80s didn't even use the word unicast because they didn't have that concept.
So anyway, I would love.
But in the 80s, go ahead.
Can we just read off the 4 drafts we're going to try talking to, top level item? Again, we know, yeah, so.
I don't have the draft names in front of me right now. I know what they all are about.
All right, well.
So we'll put links. We'll put links to the 4 drafts in the write-up for this as well, so that folks can go and read them.
Well,
yeah. To give just like a really high level overview, there's 4 drafts out there that are talking about the mechanics of basically proposing reusing certain address ranges. One of which is the loopback space 127.00/16. We talked about 240/4. There was zeroth networking, I think. Was that one of them?
0/8.
Yep. And a few other addresses. So we'll link to the GitHub page, like Nick said. We'll link that has a lot of really good info there, and we'll link the drafts as well.
Okay. I had a lot of fun digging through the history of this stuff. It was an interesting time. Can we start with one? Can we start with 240?
I was just going to say I've also enjoyed the history part.
Yeah.
And we've gotten a lot of help, and John has gotten a lot of help from people on mailing lists who
it was wonderful that
at least are happy to talk about why did the internet end up the way it is, even if they don't necessarily agree about what it should do next.
The Internet History mailing list on postel.org was great. I got a whole bunch of Steve Crocker, got a whole lot of people reminiscing about how we laid out the numbering scheme. It's really fun. So. But anyway, 240/4 is 260 million IPv4 addresses.
And that used to be called Class E. And so people who haven't weaned themselves off of the classful terminology will sometimes still say Class E.
So they were reserved for experimentation. And no experimentation actually really took place. Ironically, Class E was used and is still partially being used by Google, at least, to help them NAT IPv4 to IPv6 today internally, which is a use case that we documented. They're trying to get away from that with something else, which again frees up 260 million addresses for some other possible use.
So it's also interesting to think there are lots of things that could have ended up being used for. There was certainly good reason to think that we might need some other kind of addressing, some other addressing model. So for example, if you go back and read the first RFC about Anycast services, they suggest that probably Anycast should have its own designated address range because routers might need to handle it specially. And that turned out not to be the way that Anycast worked, but people didn't know that, right? It was perfectly plausible to think, oh, maybe we'll put all of the Anycast stuff in 240 somewhere. And then the routers will have a special case about how do you route Anycast addresses. Also, some of the IPv6 transition mechanisms proposed having like an escape code, kind of like with UTF-8, how you get multi-byte characters. So there were proposals like, oh, we should have special IPv4 addresses which indicate to a router that this is actually an encapsulated v6 packet, and then the router will route it differently. So there are lots of ideas. I'm even forgetting one that I brought up on a mailing list where it was plausible that we would want 240/4 for something that was not just regular plain vanilla unicast. But as Dave said, it just didn't happen that way. None of those experiments ended up becoming important on the actual internet. And so we still have those hundreds of millions of addresses that are sitting around. In some other RFCs, they're referred to as future use area. And so John has said, well, the future is here and it wants unicast addresses.
And he's right.
Yeah. And for those addresses in particular, there's a very large block of them. They're contiguous. And with the exception of the all ones address, 255.255.255.255, none of them have any other official meaning. They're just reserved for future use. But the problem is that the RFCs said that it was invalid or illegal or forbidden for them to appear on the wire. And so a lot of operating systems put in one line of code where they do some mask against an address, and if it ends up in that range, then they break out of the function and don't process or don't forward the packet. And as Dave said, a lot of operating systems actually undid that in 2008 in response to this prior proposal. And having worked on some of this stuff now, in terms of proposing operating system changes, I've seen it's generally one line of code. It's generally one line of code for each special case. Generally, if you take it out, that special case goes away.
And
so, yeah, and it's faster. You don't even have to do this comparison.
No, so I started this project, got in this project before Seth did, and it took a lot of time for John to convince me to look into this. I had been an IPv6 advocate for a long time, but I was certainly feeling the pressure. And the growth curve, I think, for IPv6, I think it's going to replace IPv4 in 2135. It's linear extrapolation, but it's actually gotten worse lately. Anyway, he convinced me to go look at the problem, and I was really shocked with what I found. As I went Googling through all the open source in the world, there's a couple really great open source search engines out there. All of it, absolutely all of it. And the only check that I saw consistently implemented was the one for multicast. In there's no checks whatsoever in every single piece of IoT code I've seen. None. They check for multicast. That's it. Because that eats space when you have 32K of RAM to play with. So it turned out really easy to find the few remaining OSs that didn't already do 240 correctly and push the patches out. Linux had one case pushed the patch out 4 years ago. It's in everything now.
So I think one of the hard things that people keep mentioning is, okay, yeah, maybe changing the code is easy. And let's play devil's advocate here a bit, or Reddit's advocate, maybe. Changing the code is easy, but what about these devices out in the field that have been there for, 20 years, haven't been touched, won't be touched? If somebody has to go and touch them, to update them to deploy these new Unicast extensions, why not touch them to update them to do IPv6?
Absolutely,
so I'd kind of like to hear
if this is an incentive for someone to deploy newer code with IPv6 support, go do that. Me removing one line of code from the kernel so you can go deploy the tens of thousands of lines for IPv6 that is required. Go for it, please. Sorry, I got really. Do both.
I've taken a slightly different angle on that in saying, depending on which kinds of devices we're talking about, and I think home routers, an area that Dave knows a ton about, are often some of the most difficult in the sense that many of them don't get software updates and stay in use for many, many, many years with no updates at all, and often are developed very cheaply by some manufacturer that throws some chipsets together, finds some software, and that's the product. And so with the exception of the home routers, I've seen v6 support in software is very, very pervasive and has been for a long time. And, if we're talking about like smartphones, and if we're talking about laptops,
yeah, we're done.
All of the current ones are already done for v6.
Yeah.
They have software updates already. And so it's not, a few people have said, like, why would you want operating system developers to spend time on this instead of v6? And I said, the operating system developers have already implemented v6. It works. And some of us have devices that fully support v6 perfectly, and our ISPs don't give it to us, right? I'm on a very, very good ISP in many ways here in San Francisco that unfortunately doesn't offer v6 to me. If it did, most of my devices would use it already because they have proper software support. So, I mean, I totally agree that it's sad and unfortunate and inappropriate that my residential ISP doesn't give me v6. I wish they would. I think they should. But I can't exactly force them to. Some people have said, well, you should switch ISPs. But I guess I haven't felt like it was enough of a priority to me that I would literally switch ISPs over it. But I do believe that it's something that my ISP ought to do and that they're not doing. And so, at least in my personal experience, I'm saying my devices actually all support it just fine already. They don't need software updates for v6. There's no competition there. But my devices do need, in some cases, a one-line software update to support some of these reserved addresses. But yeah, there are lots of devices of all sorts that are not getting software updates at all. And even if we don't think of it as why not update them for v6, and I would agree with Dave, if this somehow could be an excuse for someone to add v6 support to a device, that would be great, and they should totally do that. I would even go further and say, if you literally had a device that you were responsible for, or a product line that you were responsible for, that didn't support v6, I would totally find it appropriate to prioritize adding v6 support or debugging v6 support above the Unicast extensions. I just have not found widespread cases in which that literal dilemma is the dilemma that presents itself. But having said that, there's also the problem that people have raised, the concern that people have raised, that if we have devices that aren't getting software updates, if they have software that hard codes 240/4 is illegal and must not appear on the wire, then if we unreserve that, those devices are not going to be willing to talk to hosts that are numbered with that range. And so there are some compatibility limits based on devices that aren't getting updates. And, Dave can speak to that from his perspective. My perspective has been, we don't actually know how many devices that is, and that would be valuable information for a variety of reasons. And we'd like to actually start trying to measure that.
Yeah.
We'd like to work with the internet measurement community, and we'd like to attempt to actually announce routes in 240 and tell people on NOG lists that we're doing so. Like, this isn't a spammer trying to squat here. This is an internet measurement test to see what the compatibility looks like. One more thing is, I feel like there's a wide range of things where devices that don't get software updates pose major compatibility changes when people are trying to fix or update other things and other protocols and other services. And I saw that firsthand because I work on and have worked on the Let's Encrypt Certificate Authority project. And there was an incident last year where the root CA that Let's Encrypt had initially been relying on to be trusted by browsers and other clients expired on schedule, predictably. And that caused fairly considerable compatibility challenges for certain sites that were using Let's Encrypt, because the root CA list often is shipped in your operating system. And so there are people who are working in the browsers and in the operating systems to maintain these lists, and they ship them in new versions of browsers or in new versions of operating systems, depending. And if that doesn't happen, eventually the root certificates expire. They're mandated by X509 standards to have an expiration date. They expire, and then those clients can no longer talk to servers that are using those roots. And so I feel like it's actually kind of a common problem and kind of an interesting problem more broadly for the internet community. Like, how do we update things? Because obviously the updates that we propose and the fixes that we propose are fairly controversial. But there are other updates that are pretty important that eventually need to happen, or that would be beneficial, or that would be important, like updating root certificates in the certificate authority system, that are also hard when devices don't get software updates and when devices never get touched, and that also do literally limit compatibility on the internet. If you have some embedded device that's trying to get some kind of IoT or SCADA interaction over TLS with a web server, you leave it there for a decade and it stops being able to talk to that web server because of the root CA expiry. And you say, oh, but I thought I could install this and then never update it and it would always work. And that may not always be true. And so I feel like that's sort of a larger conversation that we need to have. And I've been very sensitized to it by working on Let's Encrypt and the certificate authority space that literally has expiration dates presented there inside the protocol.
3 things that I wanted to touch upon. IPv stacks on the IoT devices are either non-existent or crappy. And I would really love to see people working on making the IoT stacks diligently IPv6 compatible. Otherwise, they're never going to do it. Remarkably, all those IoT stacks will talk to all these address ranges we're talking about already. So we could actually build a world for IoT out of this with what's actually available today. Don't need to update them all to IPv6. So that's a big substantial plus. Another thing about these address ranges, the elephant in the room is, for example, is the only operating system that can't talk to 240/4 is Windows. And I take a great amount of joy in the idea of a whole section of the internet completely immune to Windows-born worms, viruses, so on. Just love that. Just love that. Yeah. So the fact that, but the more broadly, I'm glad you're laughing. I do it. 33,000 worms gone. Can't touch my server. And I forget how many worms it was in the end. But that actually that points to my larger point in that limited connectivity of a sort is actually a benefit. Okay, so I just said all these IoT devices can probably connect to 240. Windows can't. Hey, that's a benefit. If you have IPv6, you can talk to IPv6. Windows used to have Teredo, and it would do IPv6 better than anybody, and better than anybody actually wanted at the time. So there's a lot of potential applicability with IP addresses that have a more limited scope, or actually flaky, total broad internet connectivity. Total connectivity is not desirable. So I want to hit that point. Go ahead.
There's an RFC somewhere that touts universal end-to-end connectivity as an engineering goal for the internet, and I would still be inclined to take that as the default. But I would say, in line with what Dave is saying, as we said, we want to do some measurement and some experimentation to see what is the actual compatibility landscape like, and to see, how bad would this be, or how not bad would this be.
I was really big on this doing the experiment. I wanted to open up 255/8 or 255/16 and announce that. Get permission to announce that. Because I think there's a whole lot of misconfigured routers out there that are possibly flip their broadcast addresses in the wrong direction. And that would suck all that traffic there. And we'd actually have an opportunity to fix those routers, which I think would be pretty neat.
I mean, I know of some similar experiments with address space that's very close to 1918 blocks that listens and collects that information, right, for misconfigured things. I also think that, having worked a lot in the service provider space, that there is definitely a trend away from a user putting their own piece of CPE in as their router, especially when you start getting into fiber to the home and cable modems. The vendors, I'm not saying it's right, wrong, whatever, but the trend is that they want to give you an all-in-one device that does your Wi-Fi and your NAT and all of those things too. The downside of that, from a technical person perspective, is now I got someone else running the border of my network and I probably can't see into that device. The upside, however, and I will say, I'll play devil's advocate here, there is an upside, is that they get regular software updates. And so people like my parents or non-technical folks, whoever, can rest assured that this device is getting updates, and they don't have to think about it anymore, because they're not going to think about it if they have their own device in there. It's going to be 10 years until it dies, and then they have to buy another one. So I think that that's changing, like I said, for better or worse. We have the advantage of that. The other thing I wanted to say is that this seems like a software issue more than anything else. And the things that limited IPv6 deployment, because this is really similar. The things that limited IPv6 deployment in the early days, you couldn't do it in hardware. Like there was no ASICs that did it. So unless these things are coded into ASICs, and the only place I can think that might be the case are some unified threat management / firewall middle box devices that might have some stuff in their ASICs that say this is always bad. Bad being, I'm air quoting here. I think that's going to be few and far between, honestly, especially anything modern that's going to have v6 support. It's going to probably not have that kind of limitation to it. So I think this is really a policy problem more than anything else.
There was a rumor that there were some Juniper devices that have a hard-coded bogon list in hardware. But I don't know.
And these are security appliances, right?
I thought, well, maybe things that are sold as firewalls, which would count as a security appliance.
Right. And I know that the old NetScreen boxes are the only place that I've ever seen this, where they had certain things that you could not change, you could not see. It was actually burned into the ASIC, like, this is experimental, you can never use it. Because we had, coming from a research institution, we had researchers that were trying to use these things, and the firewalls were silently dropping them. So that's the only time I've ever seen that type of behavior. And that was like 15 years ago. I would hope that the newer devices don't have any of that you can't see.
I want to run the experiment. Someone can identify the harm.
Yeah, I endorse this. Great.
Yeah, I think that's the big takeaway for me is, it's one of those things that, it's valuable to try. I think it's a very interesting topic to talk about. And, I'm a big proponent of, let's see if it's possible versus just immediately dismissing something. And I mean, that's why, I was excited to have y'all come on here, is just to, be able to hear your perspective on this and why you're trying to push this and, why you think it'd be beneficial for the internet. Because, yeah, I think we're just too quick to jump to,
Maybe we could go ahead and give the description of the other address ranges.
Yeah, I wanted to talk about 0. All right, so I want to look. This is wonderful history. 0 was supposed to be how we were supposed to configure our networks in 1982. That's what we laid it out for. We're going to use 0. We had a really weird technique was how we would configure stuff. Ethernet arrived and completely obsoleted that. We invented BootP, and that didn't work so well. John worked on BootP, John Gilmore, and then we did DHCP. And all the reasoning for having a 0th network, 0/8, completely vanished by 1986. There's no reason to reserve it at all. I ripped the code that's doing that check out of Linux with great joy about 4 years ago. It wasn't in anything else. And I've been saving it now ever since.
One of the things that's been really striking about this is that when changes like this have been made, no one has noticed. So when the 240/4 change went into Linux, not because of us, in 2008, in response to the Fuller, and Meyer draft, no one noticed. And when Dave's change for 0/8 went into Linux, no one noticed. And when so my change has gone in for the lowest address.
Oh, that's a good one.
Another category of.
It's an easy one, too. I don't get the wrap soon. Sorry. The single most beneficial patch that's come out of this effort is Seth's patch. Seth?
Well, so my patch for the lowest address removes the duplicate broadcast address on every network segment. So if you have a /24, then you would have .0 as a broadcast address and .255 as a broadcast address, which is purely a historical accident having to do with different TCP/IP implementations in 1983, having made different decisions about what the broadcast address should be. Everyone subsequently agreed that it should be the high one and not the low one, but they kept worrying, what if there are still devices out there that need to be the low one? Which there aren't.
In the audience, is there anybody still running BSD 4.3? Please call.
4.2.
4.2.
I think 4.3 is the one that.
Careful. If you've seen our website, you know that just might be true. So
get some therapy. But anyway.
So a really cool thing about getting rid of the duplicate broadcast address is that from the point of view of anyone outside of your LAN, it's actually already permissible under existing RFCs. The only behavior that we violate the RFC for is inside of your LAN, the fact that your router is allowed to talk to whatever device you've numbered with the .0. But the RFCs actually not only don't prohibit, the .0 from being used outside your LAN. They require it because they don't allow you to make an assumption about the net mask of a distant network. So you're not allowed to assume that that .0 is or is not broadcast, because you would be assuming that you knew where the net mask boundaries fall. And you can go on the AWS connectivity test page, and they have a whole bunch of .0 addresses that you can ping. And if you can ping those, or if you can load web pages from them, then you've proven the compatibility of that particular change. And so my patch for that has landed in Linux. It hasn't percolated out into distributions yet, but we're looking forward to that. And again,
no one's going to notice.
That actually due under existing standards. So that's cool if people don't want the standards to change. At least we've got something to offer them in terms of freeing up a few addresses.
The case for me is that I really like the world where you could have a static IP address or static IP address range. I'd have a 27 or a /29 from my ISP, and I'd use them up for my services on my edge. So this makes /30 have a whole bunch of addresses. /29, you get an extra address per. And as we have this address crunch for people that are still using real addressing, I think we just freed up potential millions additional addresses for people to use in the long run. So we did 0, we did 0th, we did 240. We didn't manage to do the one that kicked off the controversy.
Oh, that one kind of needs its own all by itself, I think. Which maybe we should do. I think that one is that one's a truckload of.
Well, I want to
something.
In that case, I want to leave the listeners with a thing. Okay, I really do want to talk to it for 1 minute, if I may.
Yeah, how about
127.0.0.1? It's a /8. We've seen uses for a couple more addresses there. Have any of you ever used Kubernetes? Have you ever seen the tangled mess, 192.168.1.1 inside that tangled mess? The concept, the idea of host-based addressing, internal to the physical host, made sense to me in helping sponsor that draft, and that, man, we can untangle some of the mess that Kubernetes is. Maybe we can make it do IPv6 better, but I've had to debug 4 containers inside of each other a couple times. And it's quintuple NAT to get from one end to the other. And my out of the box thinking in doing the 127 thing was that, hey, maybe we could get rid of some of the mess in Kubernetes. That's all I'm going to say about it. The draft merely proposes that we cut the 127 from an 8 to a 16 and reuse the rest somehow for Unicast.
Much as IPv6 just has :1 as the only loopback address.
Yeah, that term.
Yep, I was just about to bring that up.
It sucks. You really need more than one local address. Let's fix IPv6 that way too. It's really helpful to have more than one local address.
Yeah, I could get on that bandwagon.
I guess we don't need 16 million of them, though.
Yes.
Let's fix the internet. Let's make it better for everybody. That's certainly the attitude that you're all taking with us today. Let's go experiment, make it better.
So I would like to say, just in terms of the IPv6 concern and so on, Dave and I have both at various times tried to promote IPv6 and encourage people to use it. And I think we both still feel that way. But some of the responses that we've gotten have effectively been saying, and in one case literally saying, we need a stick to force people onto IPv6. And v4 address scarcity and v4 addresses being expensive and hard to obtain is part of that stick that will force people onto v6. And I just am not persuaded that we're going to force people onto v6 that way. While I think that v6 is very important and very desirable, and I really do want to encourage people to adopt it, I find it hard to agree with the idea that doing things to make v4 work better, or attempting to alleviate or manage or mitigate the address scarcity, should be thought of as bad because it might weaken someone's resolve to stop using v4. Sorry if that's too many negatives in there.
No, I don't disagree with that. And I also would point to the fact that what happens when you attempt to force humans to do anything? Like, how often does that really work that well? I mean, I get, okay, so you need a business case, blah, blah, blah. Okay, that's legitimate, and I don't disagree with that. But I also think that forcing someone to do something, which is effectively what's being proposed there, is also not the right way. I think fixing some technical debt is mutually exclusive from deploying the current generation, underlying protocol. That's all I see it as. Let's fix some technical debt with v4. We can continue to use that because, let's be honest, I've been in the v6 world a very long time, and v4 isn't going to go away. We may do a whole lot of v6 only networks, but there's always going to be something that isn't, and we just need to accept that. Everything, just like everything in IT and in life, the answer is always it depends, right? I don't see any reason that all of these things can't happen. And I definitely think that, the experimenting with some of this stuff on the global internet is at least worth going through the thought exercise of how that would happen. Because that would actually answer a lot of questions. I think the apprehension of testing that is high because people don't know what will happen, right? But the value that you would gain from that, I don't think anything's going to catch on fire and explode.
But it would explode in the last 10 years if it hadn't already. So,
exactly.
And if there did turn out to somehow be... So having looked at this code, it's typically just a one-line test. So it's very unlikely that it would cause the machine to break. But if there were some machine that were actually harmed by receiving packets from a historically reserved address, that would be very important to know about, because it would be like the ping of death or something, as a denial of service risk that needs to be patched in its own right.
Exactly. For all the kids out there, that was very much a thing.
By the way, I know we're out of time. The Unicast idea came up, and the idea of crutching along with IPv4 is still part of this. IPv6 by 2135. How flexible is Unicast? I have an open question. I don't know the answer to this. Someday, could Google use 8.8.8/24 for all of its quick UDP traffic? All of it. Unicast.
Probably. I mean, it's a global Unicast block that's announced everywhere. I mean, they're already doing essentially that for their DNS.
Since Dave has mentioned a public DNS service consisting of 4 copies of the same octet, I would just like to mention that I have often tried to make an analogy to 1.1.1.1, because we know that when 1.1.1.1, which is fun to say, was introduced, it had a lot of reachability problems, because there were various networks that said 1.1.1.1 isn't a legal address. What are you talking about? And Cloudflare actually set up a whole project and a whole forum and everything to track complaints about that, and they solicited trace routes, and they solicited community input, and they worked really hard together with their users to track down who is blocking this, who is dropping it, what devices, and they overwhelmingly got it fixed. Partly because it was a useful service and there was a consensus that actually technically it should work. And they went and approached a lot of ISPs and got them to change their configuration. And now they have excellent reachability, but they didn't at first. They had to build up to that. They had to debogenize it. Now, obviously, if there are things that could be in ASICs and so on, then we might not be able to achieve that level of debug organization, for example, for 240/4. But we've seen that Cloudflare approaching this as an incremental improvement actually made a lot of progress, because they had people who cared about it and they had a shared understanding that it should work, and they had tools to track down where the obstacles were. And so I've thought
it was very quick progress too. That shouldn't be understated. That they did that very quickly in the global scale.
Yes.
Planning, but a year of deployment, they really ratcheted way up very quickly.
Yeah.
So my ideal scenario is that at some point, after these changes are ubiquitous in current software and there's a strong consensus in favor of them, assuming that the consensus is that they ought to be used as public address space, which we haven't assumed, right? They could be used for other applications. That we would try to have a process like the 1.1.1.1 process. That's like, okay, everybody, we know that you have been blocking this. We're not mad at you for it. Now we want you to unblock it. Just try to track down those places and have users participate in the community effort.
That's a great thing. I think it's worth spending time on. I do think we're a little over an hour now. We could probably go on for at least another hour. But I fear that may be a little much for our listeners. This is a whole lot here for folks to digest. So maybe we should think about doing a follow-up with this, because I certainly think there's enough content and enough personality here in this 4-window room that we got going on here virtually that we could do that pretty easily.
Let's see if your user base unleashes the pitchforks and the other tools. And I would really like to take on someone who's strongly the other side. But I'm really hoping that I think we're on the other side here too. I also want to put out a plug. This stuff works with WireGuard. You can set it up and test in your own networks already. And if you go to DNS, you can look for bigbangburgerbar.taht.net or milliways.taht.net for 0.0.0.1 or 255.255.254.
Oh, it's the restaurant at the end of the universe.
No.
That's awesome.
And that's been my test bed for 5 years.
Oh, that's funny. So that's where you reach Dave. We usually go around the room at the end and go, "Hey, where do we find you?" Well, now we already know where to find Dave. What was it again? Big Burger? What can you say?
Milliways.taht.net.
The Douglas Adams restaurant at the end of the universe.
So Seth, where could people find you on the internet if they want to have discussions or talk to you? Twitter or blog? Yell at you on Twitter or yell at you on Reddit?
So I think the best thing is probably send me an email. My last name, Schoen, @loyalty.org. You can send me a note and I'm happy to talk about these things.
And be polite, people.
Yeah, and we do have a GitHub project page for this. Someone filed an issue. If you want to see some of the negativity out there, especially about 127, there's an open issue on our page.
It's like literally blood dripping out of the bug report.
It's always funny to have a GitHub page and then have people, they can file bugs. So basically someone filed a bug like, "I hate your idea." But if people have slightly more constructive or slightly more polite issues that they want to file, they can definitely go to the Unicast extension GitHub page and file them. We can talk about them. You can also technically join the IETF INT area working group mailing list technically, all of our work is open for discussion there. There hasn't been a lot of discussion after the initial blow up, but we have proposed our 4 drafts to the Inter-Area Working Group. And so someone who wanted to talk about them substantively in public could choose to join Inter-Area, whether you support the drafts or don't, and talk about your ideas about them. And we'd be happy to have that conversation. And of course, if people know particular reasons that would be obstacles or difficulties, it's a valuable part of the process that we learn about them. So we had someone who contacted us who said, I'm making an unofficial use of 127 and I'm so mad at you for wanting to use it because you would break my unofficial use. And I thought, the whole reason that we have these drafts and these public forums and everything is so that we can understand the landscape. So we're not necessarily saying we're going to be indifferent to your existing use and we're going to step on it. We're saying we should have an internet community, standards community discussion about whether this could be made to work at some point.
Yeah, Chris and I have run into a similar experience with someone using unofficial space for a draft that we helped create in the V6 world. So, I would encourage folks to, join the list, get involved, help change the world. That's why these things exist. So you don't have to agree. You don't have to disagree, just get involved. And that would be my parting comment for this. And with that, we haven't heard from Chris. We don't know where to find Chris on the internet. Where can we find him?
Yeah, I wouldn't recommend looking me up, but you sure can on Twitter at CrankyNetMan, my blog /64.tech, and you can always find me on the internet. I'm around, always there.
modem.show, CrankyNetMan. I'm Nick Braulio at Forwarding Plane on the Twitters that I've actually been paying a little more attention to. The blog that is woefully unmaintained. And various Slack groups. So if you're looking for any of us, that's where to find us. Parting thought. What is it they used to do on the Daily Show? The moment is in. The moment is in is get involved, change the world. Amen. Thanks for listening.
Thank you for tuning into the Modem Podcast, where yesterday's modems are today's transponders. For more information or to request a topic, please visit modem.show.